This is an introduction to section 15.3, conservation of linear momentum for a system of particles. If you take a look at equation 15.8, this is similar to equation 15.6. In equation 15.6, we have the total initial momentum plus the impulse is equal to the total final momentum for a system of particles, which is shown in figure 15.4. In equation 15.8, the external impulses, the sum of the external impulses is equal to 0. This equation is similar to what we had back in equation 14, or in section 14.6, equation 14.21, when we are doing work energy. Equation 14.21 is the work energy conservation law when the work done by non-conservative forces is equal to 0. However, I don't recommend using equation 14.21. Neither do I recommend using equation 15.8 because those equations only apply in specific situations. Instead, I would recommend sticking with equation 14.20 when you're doing work energy and equation 15.3 when you're looking at impulse momentum. And you should check to make sure that either the work done by non-conservative forces is equal to 0 for equation 14.20, or that the sum of the external impulses is equal to 0 when you're using equation 15.3. This should help you to avoid making mistakes. In section 15.3, the sum of the external impulses is always going to be equal to 0. So if you know you're doing a problem from section 15.3 and you stick with this equation here, you can't go wrong. But if you're doing a review problem from the end of this chapter, or a quiz problem or an exam problem, you won't know whether the sum of the external impulses is equal to 0 until you check. So you should do that. If you go back to section 15.2, where they have the figure for the system of particles, we are choosing a system, and the system may contain more than one particle. And if you have two particles here, they exert forces on each other by Newton's third law. We have a pair of forces here, and so if you add the impulse from this force to the impulse from that force, those would cancel out. If you have an external force acting on the system, then that would give you, if you have a external force acting on the system, this would give you an external impulse. You should also read page 240 because it explains to you how you can use the mass center of the system in our equation for impulse momentum. So instead of summing up the momentum that you have for each individual particle in the system, instead you can look at the entire mass plus the velocity that you have for the mass center. So we are going to be doing that in equation 15.3. So in the absence of any external forces, we have the initial momentum is equal to the final momentum when the net external force is equal to 0. Okay, but we're going to stick with equation 15.3 and always check to make sure the external force is equal to 0 for our system.